Hello. In this video, I wanted to illustrate the exploratory data analysis case study I discussed yesterday in the crash course. So when you log into the Research Hub, you're going to see the slides from yesterday. And below that, there are the lab details. So if you go into the case details, you're going to see the description of the case for all the 4 days. The summary talks about the insights we got from the exploratory data analysis. And the third link we put together basically illustrates how to use QSandbox for your labs. So if you go through it, you're going to see details on the various screens you're going to go through when you're working with the QSandbox for the first time, how to log in, how to launch your experiment, and how to go about running through all the experiments which you're going to be going through these 4 days. So let me illustrate the first lab, the exploratory data analysis lab, which we discussed in the session yesterday. So basically, if you click on this Run Lab on QSandbox, you'll be asked to log into the QSandbox, and you're going to see the Jupyter notebook associated with the first lab. So you just basically need to say that I want to run the QSandbox, choose whether you want to run it on Amazon or Google, and then you can select the instance, and we are using Docker behind the scenes, so you select the Docker Hub project, and you can select a machine type. Here we're just going to use M3 Medium. And for the duration, I would recommend, if you're just planning to do a simple 1-hour lab, just put in 1. You can always extend the lab. But please note that you have 50 credits and use your time judiciously. If you use up all your credits, you may not be able to run through the rest of the labs. So once you start the lab, you say Submit. And if you go to your tasks, you're going to see a view like this. Here you can start your lab. In case you want to extend, you can add more hours to your lab. But the point here being that once the lab starts, you will be able to access the Jupyter notebooks. So once you go into the Jupyter notebooks, you need to go into the specific project folder and look at the notebook. The first lab you're going to go through is the exploratory data analysis lab. So let me kind of do a quick review of what we discussed yesterday. So this lab's been written in Python. And here in the first segment, we are just basically importing a bunch of Python libraries. We are using pandas to bring in the data set. The data is in the form of a CSV file. So if you go into the project directory and the data directory, you're going to see the CSV file. This is the Lending Club data set, which is a summarized or a curated version of the Lending Club data set we're going to be using for this experiment. So we see that when we explore the data, we have a lot of features in here, the debt to income ratio, for example, the grade of the loan, the type of the annual income of the person, the title, the FICO scores, the funded amount, etc., etc. So we have chosen close to 10,000 records in here, and we have 17 different features. So obviously, if we start exploring the data one by one, we may not get very many insights. So we want to do a summary analysis and get to see what kind of data we are working with. So let's explore that using some graphics capabilities in Python. So here we are using Matplotlib to plot some of these features. There are also a bunch of other libraries. One is called Seaborn, another one is called Plotly you could use for plotting out some of these data sets. So here we are looking at the counts of different kinds of features we have. We have 17 different features in here. So let's start taking a look at the numerical and categorical data individually. So first we took a look at the numerical data, and if we draw a correlation matrix and plot it out, you can see that the interest rate is highly correlated with annual income and somewhat correlated with the debt to income ratio, obviously. But some of the other features may not be highly correlated with that of the interest rate. We can also look at some of the categorical features. We see that a lot of people are taking these loans for various purposes, like buying a car or to consolidate debt or to pay off credit card loans or for home improvements, etc. So you can visualize it and figure out like how many people are using it for what are the various categories for each of these categorical features. And then you can look at some of the summary measures on the variation in loan, the interest rates, the installments, the annual income, etc. So you can see that, for example, people are on an average borrowing around $12,800 with a standard deviation of close to $8,500, which means that, if you assume that the data is normally distributed, 68% of the people are borrowing anywhere between $12,800 plus or minus $8,500. Now, you can look at some of the summary of the loan amounts, and you can see that the various loan amounts and the different people. So most likely the people are going to be borrowing somewhere in the range of $5 to $10 to $12,000. You can also see the summary of the annual income, and you can see most people have an annual income somewhere in the range of $30,000 to $40,000 to close to $70,000 to $80,000. Okay, so the purpose of the loans, we just are going to illustrate that. Most people are taking this loan for debt consolidation. And as we mentioned in the case before, these are typically people who may have maxed out on their credit cards or their ability to borrow in traditional channels, and that's why they're coming to Lending Club to get an additional loan or to clear off the loans they've already had. So you can also look at it in a different way, the same information. You can look at the various states these people are resident in. We haven't normalized the data, but you can see that California and New York has most of the customers for the data set we are currently using. So just wanted to illustrate in this quick case study that if you're working with a large data set, typically before you start building out machine learning models, you need to understand the kind of data you're working with. So your data could have numerical and categorical features, and using some basic visualization capabilities in Python, you can get a better understanding of the data. And from there, you can use this information to start structuring your models, which we will talk about more in Lab 2. Thank you so much for your attention, and I look forward to seeing you in Lab 2.